everyone, and welcome to the final video on the tutorial series. It's been a long time coming, but it's about time I finish off this final part and show you guys how to figure out the bounds and make sure we don't have any of those black edges around the image, like the last video left in the series was. So this is where the series left us last time. We have this image and there's a black bar on the left and right, because when we're applying the blur, we only iterate to 0 until the end of the image minus the radius. So that's why the blurs, that explains the black bars around the perimeter. And then the top and left part of the image, we have this sort of soft and faded black edge, because we're mixing the color black with our image colors, and we don't want to do that either. So we're going to fix this black perimeter by only mixing colors and sampling from colors that are on the source image, not this black mixing we've been doing. So the first thing we are going to do is we're going to hop into the Gaussian Blur.java class, and we're going to remove this innermost try catch block. This is what we kind of lazily put in here, where we just, if we happen to go out of bounds, we don't care. We're just going to print out of bounds and not handle anything. Or, I mean, we're handling it in a try catch, but we're not doing the proper processing that we should be doing. Instead, we're going to need to define some if statements and handle the execution of these sample x and sample y variables, and you want to sample from a certain spot on the image instead of just not doing anything, letting the color constructor class throw some sort of exception because we're trying to sample like -1, or maybe we're trying to sample, well, we're not sampling outside the image right now because we're only iterating from the image from 0 to the image width minus the radius. So we're not actually going out of bounds. Our indices are never exceeding outside of our image, but we are going outside of our image negative wise. We're not exceeding by a positive number, we're exceeding by a negative number, if that makes sense. Hopefully it does. The first if statement that we have defined is a way for us to handle if our x value exceeds the width of the image. So if we go outside the max pixel of our image, the second if statement checks to see if we go outside our max height, and then the last two do essentially the same thing, but we check to see if we step outside of the image in a negative direction. And we need these 4 cases to be handled in a way that redefines what sample x and sample y it will be. Let's handle the last 2 if statements first. And if we are going below 0, we just want to take the absolute value of whatever we have. That's a simple solution. And then the same thing for the y, sample y. If that's negative, we're just going to take the absolute value of it. That way, as we become more negative, we just reflect across our image and sample a reflection. This strategy lets us sample further into the image and get still a diverse set of color that's related to our target pixel. If we decide to try and run it now, we should have eliminated the soft edges on the left and top part of the image. All right, so press F5, refreshing the Eclipse resource. You can see that we buffed out that soft black sort of blend. And now we can work on the top 2 cases, and that'll define the left and bottom part of the bars, the black bars, and get those filled in. First case and second case, we're going to use a very similar strategy to the absolute value, except instead of checking to see if we exceed 0, we're going to check to see if we exceed the boundary image get width. Instead of iterating from 0 to get width minus radius, we want to iterate from 0 to get width, and we don't want to subtract the radius, because we want to sample every pixel on the image. The error offset will be defined as the sample x when it's bigger, subtracted by the upper boundary. This is going to give us how far off the image we are trying to sample from, and it's going to reflect us back into the center of the image. We know that the error offset will always be a positive number because sample x will always be bigger than the get width boundary. So when we subtract a bigger number by the smaller number, we'll always get a positive number. And we take this positive number and we subtract it from the width of the image, our boundary. We subtract it from our boundary, and that'll give us the new sample position that is going to be approaching the center of the image. The process is the exact same for sample y. So when you copy and paste it over, make sure to replace the x's with y's and the widths with heights. I forgot to do that. I forgot to get all the x's and all the y's. So I stumble into a problem that you'll see. Just switch that x to a y, or you can select a couple lines and press Control F and do an automated find and replace, which I accidentally did incorrectly. Again, I did find y replace with x. We want to find x and replace with y, but just make sure all your x's and y's are swapped properly. There'll be no problem. It ran correctly as expected. Press F5 to refresh the resource, and you can see that the whole image looks like it's been blurred properly, and that GTA loading screen is finally blurred correctly. That's it for the Gaussian Blur tutorial series. Thank you for watching. If you want the source code to any of these projects, you can join my Patreon, and I post all the source code there, and I'll give you a link to the private repository in GitHub. Don't be afraid to send an email if you need help with a specific question. I can always answer those, or post in the comments. A lot of people have gotten their questions answered by posting their problem in the comments. And let me know if there's any other types of videos you'd like to see me make. I'll be happy to do those.